I recently developed an open source custom web search agent that tries to mimic what Perplexity does. My custom web search agent works with Ollama, so you can use the local LLMs. It also works with most Hugging Face open source large language models, and also works with the OpenAI APIs. This is the final video in a series of videos where I've been putting my custom web search agent to the test. I've been doing this by running parallel tests on a series of questions that I've crafted and then ranking each model's performance. The purpose of ranking each model's performance is to see whether I can get close to the performance of Perplexity or even beat its performance with any of the open source models or any of the OpenAI models. In this video, I'm going to be testing the final three models, which are the Codestral model from Mistral AI, the Mixtral 8 times 7 billion model, and also the GPT4o model. So for the open source models, which are the Codestral model and the Mixtral model, I've run the tests ahead of time and I'll be going through the results of the test. For the GPT4o model, I'll be doing a live run so that those of you that haven't watched the previous videos can see how the custom web search agent actually works. For those of you that are interested, the GitHub repo containing the code for this custom web search agent is available to you in the description to this video. So check that out if you want. I want to quickly run through the test questions and then I'm going to talk about the results of previous tests. The test questions are fairly straightforward. At the bottom here, you see the easiest question that's awarded the least points. And at the top, you have the most complex question that's awarded the most points, which is 7. The top questions tend to be multi-hop questions. So things like, how many Germans live in a colonial holding in Aruba's continent that was governed by Cristiano Ronaldo's country? So that's the second to top question here. And it's multi-hop because there are a number of questions you need to answer before you can get to the right answer. So for example, you need Aruba's continent, which is South America. Then you need to know Ronaldo's birthplace, which is Portugal. And then you need to know Portugal's colonial holdings in South America, which is Brazil. And then you can answer the question about how many Germans are in that colonial holding, which is, according to the data, 5 million. That's it. I ask each model these questions in turn, and I will allocate points based on how many questions they get right. Because we want to compare my custom web search agent to Perplexity, when we're talking about getting a right answer, we also want to have a citation alongside that answer. So if the right answer is delivered, the correct answer is delivered, but without a citation, it doesn't count as a correct answer. So that's really important here. Otherwise, there's no sense benchmarking this against Perplexity. Because one of the great things about Perplexity is that it also provides citations for whatever answer it delivers to you. Let's take a quick detour to the previous results of the tests that I've run. So the first ever test I run was on the Llama 3 8 billion instruct model. That's the GGUF version running locally through Ollama. And that didn't perform very well. I think it didn't even get a single question on that run. So that's scored as the F tier. Then in no particular order, we had the by 3 medium, 128K instruct. So I did that in the last video I recorded before this one. And I was quite disappointed in the performance of that model. I found that it was getting confused, especially as we ran through more iterations or we started to get through to the multi-op questions. So that scored between D and F tier. Then we tested GPT 3.5 Turbo. And as far as I'm concerned, this is kind of like a benchmark for the larger models to be able to beat. And that scored between C and D tier, getting some of the earlier questions right, but particularly struggling on the multi-op questions and also struggling with the quality assessment portion of the agent workflow. Then we tested the Llama 3 70 billion instruct, and that came close to matching the performance of Perplexity. And then we tested a fine-tuned version of the Llama 3 70 billion model. So this was fine-tuned not on the instruct model, but on the Llama 3 70 billion base model by 10x chat. And this version outperformed the Llama 3 70 billion instruct model, which of course is fine-tuned by Meta themselves, and almost matched the performance of Perplexity entirely. I think I awarded half a point on one of the questions because it didn't exactly provide the source. The source it provided was behind a paywall, but I think technically that would have been able to pass on another day if it provided another source. So essentially we got a performance match with this Llama 3 10x chat 70 billion model. If you want to see that, I will link the video in the description to this one. So now we're going to see if any of the models I run today, including GPT4o, Mixtral, or the model from Mistral, the code model, can match or beat the performance of Perplexity. I'll be running the GPT4o model last, so stay tuned to the end for that. And stay tuned for the open source models, because I think there's a few surprises in there that may indeed shock some of you. So stay tuned for those. Right, I'm aware that some of you might not have seen my previous videos on this custom web search agent, so it's worth just running through quickly how the agent works. And I'm showing you through this schematic diagram that I created. If you want to review this diagram, it's available to you in the GitHub repo linked in the description to this video. So a user query comes in, and the first step is that the query is addressed by a planning agent. And the job of that planning agent is to simply take that query and break it down into searchable queries. The reason we're doing this is to hopefully be able to address multi-hop questions as well, which might require a more sophisticated search plan. So that's what the planning agent is doing. It's breaking that initial user query out into searchable queries, which can be passed into a search engine. And then there's a web searcher tool. And the web searcher tool takes that search query and passes it into a search engine and returns the search engine results page. And from there, selects the best page to then scrape the text from that URL for that best page. And then that's passed to an integration agent. And here there's a decision node. So if the information is sufficient to answer the question, the integration agent goes on ahead and produces a response to the query, at which point it's checked by a quality assurance agent. So this is a check response here. If it meets the criteria, we deliver the final response. If it doesn't meet the criteria, there's some feedback provided to the integration agent. And actually, this loop does start again from the planning agent if it doesn't meet the criteria. So it's not clear on this diagram, but it does go back to the planning agent. But feedback is provided to the integration agent. If the integration agent doesn't have enough information to answer the query, then we provide feedback to the planning agent, and the planning agent adjusts its plan based on the feedback from the integration agent. And then there's a short-term memory store, which is a memory.json file that has all of the previous responses from the integration agent. And that helps in making sure that the integration agent is aware of what it's previously said, and the planning agent is aware of the feedback from the integration agent over many iterations. Now, look, this custom web search agent isn't perfect, and there is definitely a lot of room for improvement. But high level, this is the approach, and this is what we will be testing in this video. I've run a test for the Mixtral 8x7 model. Let's see how that model performed with the custom web search agents on my questions. So the first question is, when did the capital of Nigeria change? The planning agent has come up with some sensible search queries. So we've got history of the capital changes in Nigeria, previous capitals of Nigeria, date of the last capital change in Nigeria, all the way down to historical context of the capital change in Nigeria. Interestingly enough, it's decided the best search query here is, when did Abuja become the capital of Nigeria? And I gather that's because the model itself has the knowledge of what is the capital of Nigeria and its weights. So it's just jumped straight to, when did Abuja become the capital of Nigeria? That's quite a direct way to do it. And then the integration agent says, based on the provided research, the capital of Nigeria changed from Lagos to Abuja on December the 12th, 1999. And we've provided the source here. And then we go to the quality assessment, and that's passed. And that makes sense to me that it would have passed. There's a reason here, but I'm not going to read that out. And then the final response is just a regurgitation of what the integration agent said, given that it has passed the quality assessment. And we have a source here. So I'm just going to go into the source for your benefit to show you that it is a valid source. But we can see Abuja is identified as the capital of Nigeria. Let's see if we can find that direct information from the source here. So we're saying it changed in December 1991. And by the way, that is the correct answer. I just want to show you for your own comfort. Yep. So we have 12th of December 1991. Right. So that's a pass for that question for the 8x7 model. Let's move on to the next question. Next question is, what is the current population of NYC? Yet again, the planning agent comes up with a plan, and it's identified the most important search, the current population of New York City. That seems to make sense to me. And what you see here is the agent actually trying a bunch of pages, but failing to connect to those pages. So it's programmed to try again and try different pages for a number of iterations before it errors out. So that's what you see here. We've done this until we actually get to a page that we can visit, which is this one, the visited sites. So you can see here the nyc.gov site. The integration agents come up with a response. Let's read that response. So it's passed by the quality assurance assessment, and it seems passable to me, but let's read the response. So the final response is, based on the information provided in the research, the current population of New York City is 8.8 million. So it's 8,804,190 as of April 1st, 2020. And it's provided the source here. I'm going to talk a little bit about the additional information it's provided here too, because I think that is an issue with this model. But let's have a look at the source to make sure that it is actually a correct source. So what it says is the population of New York was 8.8 8 million. And we can see that is exactly what we have here as of the 1st of April 21. And it's kindly provided that in the research for us, which is fantastic. You'll see that here. So that has worked. One of the issues I'm finding is that it's then gone on to say, to answer the remaining parts of the query, I would need more up-to-date information. It's answered the query directly and comprehensively already, and to the extent where we've passed it with the quality assurance. So this stuff seems to be a bit superfluous. It could have just stopped here, but it's gone on to do some additional answering. And I think that might cause problems later down the line, but we'll see. So that's a pass for the second question for the Mixtral 8x7 model. Let's move on to the third question, which is who won the Premier League 2023-2024 season? So we've come up with some searches from the planning agent, and it's identified Premier League 2023-2024 winners, which is a good search. And you can see we've actually provided that search. And then we've pulled from the Wikipedia page. And the integration agent has delivered an answer. Based on the information provided in the research, Manchester City won the Premier League. And we've stopped here. We haven't completed the response. And what's interesting is, obviously, we've failed this because we haven't provided any citations. And you can see that the quality assessment process says the response is relevant, but it is incoherent and incomprehensive. The response only provides partial information about the winner of the Premier League 2023-2024 season and does not have any citations, which I would agree with. So that quality assessment is working well. The planning agent then says, based on the feedback, I can confirm that Manchester City won the Premier League 2023-2024 season. However, to cross-check and ensure accuracy of the information, I would suggest the following search. Manchester City winning the Premier League 2023-2024 season confirmation. So this is part of that feedback loop because it didn't pass the quality assessment. This will help confirm Manchester City as the winners of the 2023-2024 Premier League season from multiple sources. Great. So we've conducted that search. You can see that in the search engine query. And now we're pulling from some different sources. So I think we're now visiting the Manchester City FC season wiki. The integration agent has now come up with a response, and that response has been marked as true. So let's evaluate this because it says it's passed the response quality assessment. So the final response is based on the research provided, Manchester City won the Premier League 2023-2024 season. And it goes on to give some more details about it. And I can tell you that's the correct answer. And I know that it's gone in it from the source because that shouldn't be in the training data for this Mixtral model, given that the Premier League season only ended a few weeks ago. So those of you based in the UK would know that. That won't be in the training data for the model. However, what's interesting here is there is no source provided. The model just seems to have stopped generating at this point. And that is a problem I found with the Mixtral models. Even when I've used them in production, I found that sometimes the models just randomly stop generating tokens. And you can see this here again. And I haven't set a max token length or anything like that. I would hope that it just goes to completion, but actually it's just stopped here, and it seems to be temperamental on deciding when to do that. If you've had those problems with Mixtral models or Mistral models before, please comment in the comment section, but that's something I've noticed. I'm going to give this half marks because technically it didn't provide the citation, although I know this is the correct answer. Let's move on to the fourth question, which is our first multi-up question. So the question is, what is the birthplace of the loser of the boxing match between Tyson Fury and Usyk? We've gone through a sensible approach with the planning agent of Tyson Fury versus Usyk boxing match results. That's sensible. That's what we want. And then we have that as a search query. Tyson Fury versus Usyk boxing match. We have found a source for this. So we've gone to ESPN. And the integration agent says, based on the research provided, actually, I won't read the integration agent first. Let's just see if we get a pass from the quality assessment. So the quality assessment has passed this, and then we've got a final response. So based on the research provided, the boxing match between Tyson Fury and Usyk occurred on May 18th, 2024, with Alexander Usyk winning the match and becoming undisputed heavyweight champion. Alexander Usyk was born in Simferopol, Ukraine. Therefore, the birthplace of the loser of the boxing match is not required, as Tyson Fury is not the loser. That doesn't make any sense. That makes zero sense. That's nonsense, actually. So that's actually a fail on question 4. And you can see the reasoning start to break down of the 8x7 model. And this is a mixture of experts model. So when it came out, I think it was one of the first open source mixture of experts models to be available to us. And there was a lot of hype around it. But yeah, that seems like a basic fail for the 8x7 model. That logic doesn't make any sense to me at all. That's a reasoning fail. Next, let's move on to question 5. Question 5 is, find me the cheapest flights to Barcelona from London for one adult leaving next month. Caveat here, I don't expect it to actually find the cheapest flights. What I expect it to do is return some sensible information about flights. So I want to see evidence that it's visited a suitable aggregator and pulled the flight information there and given us some flights for one adult, let's say. If it's not in the next month, but it's ballpark, that's a pass in my eyes. So again, planning agent has come up with some sensible search queries. Cheapest flights from London to Barcelona next month. We've tried a bunch of websites, but the only one that's actually worked is the Skyscanner one, and this is a common issue here. It's because of the scraper I built. It's rather rudimentary. And then we have some information returned by the integration agent. Let's see if we get this as a pass. So it has passed the response quality assessment. Let's see what the response is. This is a bit difficult to read, but it's saying from Skyscanner, the cheapest flights from London to Barcelona next month, the cheapest flights from London to Barcelona are available from 28 return. And it's saying one such flight departs September the 1st, 2024 with Ryanair. So September the 1st, 2024 with Ryanair, that's what it's saying as the cheapest flight. Let's see if we can actually link to this directly instead of having to copy it out manually. So that has actually worked. It's saying £28 is the cheapest one. And we can see that £28 flight. It said with Ryanair, but these all seem to be with Vueling. So this isn't with Ryanair actually. Yeah, these are with Vueling. So there is a little bit of hallucination there actually. There is a flight with Ryanair. I can see it here, but that's from £30. It's not the £28 flight. That's with Vueling Airlines. And yes, the 1st of September flight is the Ryanair flight. I guess it's technically not incorrect because it doesn't say specifically that flight is £28. What it says is the cheapest flights from London to Barcelona next month are available from 28 return, which is correct. It says one such flight departs on September the 1st, 2024 with Ryanair from London Stansted to Barcelona and returns September the 11th, 2024 with Vueling Airlines from Barcelona to London Gatwick. And I believe the flight they're talking about is this one. So technically that is a pass. I will give it as a pass. I don't think that's a perfect answer. I think it could have given us this information here, but it chose to give this one. It might be the way that it's being scraped. It's suboptimal for the model to return from the way the website is scraped or something like that. I don't know what it is, but I'll give that as a pass for question 5. And you can see here, it's starting to actually include some of the information that I used to prompt the model in the output, which again, I've noticed with a few models, actually, I can't remember the last model I tested that was doing that too, but that's not ideal, especially if you're trying to create a product that's going to face customers or, if you want to use this for yourself, you don't want all of this stuff that's meant to be in the system prompt to be appearing when you generate the output. And I've noticed that again with Mixtral. I don't know if it's to do with stock tokens or prompt formats. It might well be to do with that. But I have noticed every time I've tried to use the Mistral or Mixtral models, occasionally it will just generate the system prompt, which isn't ideal. Let's move on to the next question, which is a multi-hop question. And it's one of our more complex multi-hop questions. How many Germans live in a colonial holding in Aruba's continent that was governed by Cristiano Ronaldo's country? So I expect this to be broken down logically, and it really hasn't identified the hops. It just goes straight to current population of Germans in Aruba, which isn't what we want. It doesn't seem to really understand this question. And it'll be interesting to see if GPT4o can actually break this out in the way we need it to break out with those logical hops. But I can already tell that this isn't going to get to the correct answer because, we're starting off on the wrong foot. But I guess, to be fair, the planning agent has identified the most important search would be German population in territories governed by Portugal. I don't think there are any existing territories governed by Portugal in South America. Correct me if I'm wrong, there might be, but let's see. So research provided does not contain information on the number of Germans living in colonial holdings in Aruba's continent that was governed by Portugal. as the focus of the research is on Germany-Portugal relations. Therefore, I am unable to provide a specific number. However, the research does mention that, and again, it doesn't complete the generation, doesn't complete the response. This is a problem. So obviously the quality assessment isn't passed, and we've stepped back in, and the planning agent has made an adjustment here to the plan. Current number of Germans living in Portuguese territories in South America. I'm not sure that this is going to work. What is the search query? So current number of Germans living in Portuguese territories in South America. Yep, we're going to be led down the wrong path here. What's interesting, though, is if you read this, the correct answer should be how many Germans in Brazil. That's what we want to get to. But if you read this, it has managed to pick up Brazil. So it says, I'm unable to provide the exact number of Germans who lived in the colonial holding in Aruba's continent that was governed by Portugal. As the research provided does not contain specific information on this topic, the focus of the research is Germany-Portugal relations and German communities in Portuguese-controlled territories in South America. So it's getting there. However, I can share some insights regarding Germans living in Portuguese territories in South America. According to the research, between 1824 and 1969, around 250,000 Germans emigrated to Brazil. It's getting there. It's getting there because Brazil is what we're actually after. So by fluke, it's kind of managed to pick up an article about German Brazilians from Wikipedia, and we're getting there, although it's the wrong time period. That's probably the closest that we've gotten with any model on this topic. And we have some sources here. It doesn't pass the quality assurance. What's the reason it doesn't pass? It says the response is coherent, well-structured, but it is incomprehensive as it does not address the query in its entirety. However, the response does provide some insights regarding Germans living in Portuguese territories in South America with citations to support the information. Okay, fine. We have some adjustments from the planning agent, and it's getting more specific now. It does seem to be narrowing down on Brazil. Let's see what the search query is. Number of Germans in Portuguese colonial holdings, Aruba's continent not available. Instead, search for German immigration to Brazil between. So that's messed up. That hasn't been able to pass the correct search query from the planning agent. So that's also a limitation in the model. And I think it's getting overwhelmed by the amount of context there now. And we've got some stuff from the integration agent. I'm not going to read all this. There's a lot there. It's probably not worth reading all of that. And we go again back to the integration agent, and we've got a pass this time. So let's see what we deemed to be a pass here. So the final response, I am unable to provide the exact number of Germans who live in the colonial holdings in Aruba's continent that was governed by Portugal. As the research provided does not contain specific information on this topic, the focus of the research is on Germany-Portugal relations and German communities in Portuguese-controlled territories in South America. However, I can share some insights regarding Germans living in Portuguese territories in South America. According to the research, between 1824 and 1969, around 250,000 Germans emigrated to Brazil, being the fourth largest immigrant community to settle in the country. By 1905, there were around 140,000 Germans living in Brazil, 131,500 of those being rich Reich nationals, and the other 8,500 being Reich citizens with 24 German consonants. Okay. So this is a tricky one because I feel it has sort of answered the question. Let's bring this up. Let's bring up the wiki pages. And I think it's not going to work because it's going to put this single quote here. So let's just see if we can get it to return without, yeah. So it does put that single quote there. I'll get rid of the single quote. Let's just bring up the source. And it's saying, let's just fact check some of these numbers. The first number is 140,000. Yeah, there we go. So it does seem like it's pulling from this source, 140,000 Germans living in Brazil. This looks familiar. So we see where this comes from. And I guess another source is this one. So I think that number looks familiar. So just to show you, 250, there we go. Approximately 250,000 Germans arrived in Brazil over more than 100 years. Are we seeing that here? Around 250,000 Germans emigrated to Brazil. So that article doesn't necessarily mention these dates, I don't believe, but what it does mention is the 250K number. That's a difficult one. That's a difficult one because it kind of has answered the question by fluke, because we got 2 Germans living in Brazil. The correct answer is actually 5 million, approximately. But we have gotten to an answer, a response of the number of Germans living in Brazil. I'm tempted to give this a pass, actually. It's really weird, but by fluke, it managed to find the right answer. And I say by fluke because I think it kind of, without breaking down the hops correctly, it kind of got there somehow. It got there by kind of coming up with some obscure logic. I would say it's relatively obscure. So I am gonna give that a pass. Strictly didn't get to the right answer, but it got to a passable answer. Now let's have a look at the last question. The last question is, what is the current weather forecast in the largest city north of the city where the team that finished second in the 2023-2024 Premier League season played its last match? So we have some sensible queries that the planning agents come up with. Let's see what the final search query we actually searches. So here we go. The search query is current weather forecast in the largest city north of the last match venue for the second place team in the 2023-2024 Premier League. That's quite a useless query. I'm sure we'll get something from Google, but that's not really what we should be trying to search. I think that's, showing the reasoning capability of the model breaking down a little bit. It should know that that's not going to get us the answer. Searching that, we should break that down a little bit more. The integration agent has provided something. Now, I'm not gonna read all of this. I'm just gonna go all the way down to the end and see the final response that we got. It looks like we're getting a bunch of false responses here. Yeah. So it actually ran out of iterations. It went all the way through and ran out of iterations. And I gather that's because, we started off on the wrong foot. Granted, I haven't read all the detail out, but it will be here all day if I do. But we weren't able to get to the final response for that. We weren't able to get to the answer for that question. So I'm going to mark the 7th question down as a fail. And now I'm going to go through and calibrate all of the responses and see where the Mixtral 8x7 model landed up on our grid. Okay, let's revisit the performance of the Mistral 8x7 on these questions. Question 1 was a pass. We got the answer relatively straightforward with that model. Question 2 was also a pass. We got an estimate of the population. Question 3, we awarded half marks because although I know that the model managed to actually identify a source and pull the correct answer in, we got Manchester City, it didn't complete its response. So we ended up providing a response without a citation. So I awarded half marks to that. Question 4 was a fail, and that was an utter failure in logic 2. Remember that because it was saying we don't need to actually know the birthplace of Tyson Fury because we know the birthplace of Usyk. That doesn't make any sense. Question 5, we passed. We managed to identify some flights. Question 6, so I know I initially said that I was going to award a pass to question 6, but actually I didn't get to the right answer. It got close, and I think this is the closest that any model has gotten. So for question 6, I am going to award half points. And question 7, we didn't get to the right answer. So in total, the 8x7 model got a total of 11.5 points. And if we move to the calibration, you can see where the Mixtral 8x7 instructor model lands. And it outperforms the GPT3.5 Turbo for sure. Definitely the quality assessment agent is a lot more sophisticated with the Mistral 8x7 instructor model, but it doesn't do quite as well for me as the Llama models. So it's not quite up there with Perplexity yet, although it was able to get to an answer for that Germans in Aruba, well, not Germans in Aruba, but that question about Germans living in the colonial holdings. And no other model on this chart has been able to do that. No other model I've tested so far. So that is a big step. And it might be something to do with that mixture of experts architecture. I'm not sure. It seems a bit inconsistent. What would be interesting is to test the larger Mixtral model that's come out, the 22, I think it's 8 by 22 or something that has come out recently. It's just unfortunate that I wasn't able to test that because of hardware limitations. Next, I'm going to run through the results of the Codestral 22B test. So that's coming up now. So I have the results of the Codestral test on screen now. And there's a few comments I want to make about Codestral. Codestral is a code generation model. So it's not actually designed, I don't believe I don't think it was designed with the purpose of being an outright agent like this. But I think there's some logic behind the theory that code generation models could work well as agents because inherently they're trained on a lot of code, and code has a lot of logic and reasoning embedded within it. And I think that reasoning can carry over to an agent workflow. Anyway, let's see how the Codestral model did on the questions and see if there's any validity to this theory. I'm going to zoom past these because I think some of them you've seen already, and I don't want to bore you with unnecessary details. So if I do zoom past some of the questions, forgive me, that's why. And where it does become a bit more interesting, I'll spend a bit more time on that. So the first question, when did the capital of Nigeria change? I'm going to zoom in a little bit. When did the capital of Nigeria change? Planning agent does come up with some good searches. So the timeline of Nigerian capital city changes, that seems like a relatively sensible search to me. I think it could probably just search when the capital of Nigeria changed. And the search query. And what I noticed with the Codestral model is that it pretty much gets this spot on every single time, whereas some of the other models will change the search query and it won't necessarily go with what the planning agent recommended. And then we get an answer, and the answer we have is the capital of Nigeria changed in 1975. In that year, General Murtala Ramat Mohammed began the process of moving the federal capital from Lagos to Nigeria. This is a weird one because the correct answer is actually 1991. That's when it officially changed. But I think this is technically correct. This is when the process began in terms of moving the capital. And if we go on BBC News, we could probably see this. Page not found. That's why, because there's a small comma here. Get rid of that comma. Here we go. So I think we said, what did we say? We said 1975, and our BBC News source. Yeah, here we go. So our BBC News source actually says General Gowon overthrown by Brigadier Murtala Ramat Mohammed, who begins the process of moving federal capital to Abuja. Look, I think technically it's the correct answer because we said when did the capital of Nigeria change? I guess change is subjective. If the process started in 1975, we could technically go with that as a correct answer. So I'm going to give that a pass. And you can see the quality assurance agent has marked that as true as well. And that final response is acceptable. Let's move on to the next question. What is the current population of NYC? We have some sensible searches here. NYC current population. We'll put that in the search engine. And then we return a figure. So this looks familiar. I think this is the same source we pulled last time. So the current population of New York City is 8.8 million. And that's pulled from the New York Gov planning site. But just for your own comfort, I'll pull that up. And do we have a current population of New York City? There it is. So that's the exact figure we quoted. That's another pass for the code model. Let's move on to the next question. The next question is about the Premier League. So it is who won the Premier League 2023-2024 season? Apologies, I'm just writing down the results of the previous two. Again, coming up with some sensible searches, it would seem on the surface. Yep. Premier League winner, 2023-2024 winner. So we have some sensible searches here. And then we return visited sites, and we have returned the NBC Sports site as the visited site. We have a source here. It's passed the quality assurance from the planning, from the quality assurance agent. So let's see, it says Manchester City won, which is the correct answer. Let's have a look at the source. Yep, that's fine. I think that's acceptable. So we can see Manchester City highlighted in that source. And we know that that's not going to be in the weights of the Codestral model. So that is a pass for question 3. It's looking good so far, and these answers look very neat and concise. And notice like it's kind of returning a regular response. And I think that's almost intrinsic to the code generation properties of the model. It's really structured, and there's definitely something about using code models for this type of exercise for sure. Let's see how it handles the multi-hop question. So the multi-hop question is next. What is the birthplace of the loser of the boxing match between Tyson Fury and Usyk? We have some searches. Tyson Fury birthplace, Usyk birthplace, Alexander Usyk birthplace. So logically, I don't think this is coherent because we want to identify the loser of the boxing match first, and the planning agent seems to not have done that. Let's see what we search. We just search straight for Alexander Usyk's birthplace. The integration agent delivers a response, and yep, it's straightforward. It's just told us the loser of the boxing match between Tyson Fury and Alexander Usyk is Alexander Usyk. That's not true. That is a complete hallucination. It's not true that Alexander Usyk lost the boxing match. It was Tyson Fury that lost the boxing match, and it's given us the birthplace of Alexander Usyk. So that's a fail. And that was a failure in logic initially with the planning agent, because what we should have searched first was the result of the boxing match between Tyson Fury and Usyk. And then once we identify the loser, we should have been able to iterate and then find the birthplace of that loser. So that's a fail. So the first multi-hop question does fail. Let's look at the next question. The next question is, find me the cheapest flights to Barcelona from London for one adult leaving next month. And we have some sensible search queries from the planning agent again. Cheapest flights to Barcelona from London, one adult leaving next month. We visit a few sites, and we failed some sites. And notice it's quite quick to move on from the failed sites, which is good, because some of the other models haven't been. They've struggled to move on from the failed sites, but this one does very well at doing that. So we go to google.com, and looks like we've picked up some stuff from Google Flights. And then the integration agent returns a response, but actually it's returned as false this time. Why is it false? The response is relevant to the query, but it doesn't provide the actual prices or flight details for a given criteria, making it incomprehensive. Okay, that's good. Do we actually get to some flights? Let's just see. Okay, so now we have met the requirements of the quality assurance agent. So let's see what we have. Based on the information provided in the research, the cheapest flights from London to Barcelona for one adult leaving next month is 28 per passenger, £28 per passenger. The flight is a return flight with Ryanair and Vueling Airlines. The outbound direct flight with Ryanair departs from London Stansted on Sunday, 1st of September, arriving in Barcelona. The inbound direct flight with Vueling Airlines departs from Barcelona Wednesday, 11th of September, arriving in London Gatwick. The price includes taxes and charges. So this is coming from Skyscanner. And I think we've been here before. We know already that information is correct from Skyscanner. But notice here that it's messing up the dates. So it's saying next month. But actually, I'm recording this video in June, and it's saying that this flight is a return flight with Ryanair and Vueling Airlines. The outbound direct flight with Ryanair departs from London Stansted on Sunday, the 1st of September. So it's getting the dates wrong. And that's might be something inherent with large language model and messing up the dates, because it is time aware, it's date time aware. In the prompt itself, it knows what date we are. So the fact that it thinks September's next month is a bit of a hallucination. But I will give it a pass on these flights, because I know we've already visited this Skyscanner website. Let's just for your comfort, I'm going to bring it up again. But we've already visited the Skyscanner website, and we know there is a £28 flight, and that is the cheapest flight. And we know there's outbound flights on the 1st of September from Stansted to Barcelona, and then from Barcelona to London Gatwick. And we are mentioning that here. So departs from London Stansted. Yeah. So that's a pass. That's a pass for question 5. It's doing quite well so far. Let's see how it handles the remaining multi-hop questions. So how many Germans live in the colonial holding in Aruba's continent that was governed by Cristiano Ronaldo's country? So we know this is a multi-hop question. Number of Germans living in Aruba. Again, that's a bit of a red herring. That's not what we want. to answer this successfully, we should break that question down into its constituent hops. I've already discussed that in detail, especially in previous videos. So now we're going to go through this whole loop of going through the integration agent. So let's see what we search. Number of Germans living in Aruba's colonial holdings governed by Cristiano Ronaldo's country. That's not really a useful search, but we have pulled up some information nonetheless. We don't get a pass from the quality assurance agent. So let's just scroll down until we do get a pass and see what happens. So we don't get a pass. That's continuing. I'm not going to read through all of this because it'd be all day, and we've broken it. So we have broken it. We haven't gotten to an answer for question 6. So that is a fail. I'm not going to go into the details of that, but we did start off on the wrong foot. Let's move on to the final question. So the final question is, what is the current weather forecast in the largest city north of the city where the team that finished second in the 2023-2024 Premier League season played its last match? Right. Planning agent comes up with what looks like sensible queries. It seems to have broken it down. 2023-2024 Premier League second place team. Makes sense. Yes, let's find that out. City where 2023-2024 Premier League second place team played its last match. Yes, sensible. Largest city north of city from search 2. Yeah, so this is how I expected to break it out. And then weather forecast. So it's broken that out sensibly. It has broken that out sensibly. It's identified the most important search as largest city north of city from search 2. I would say the most important search is search 1 because we need to find that information first. The integration agent, the research provided does not contain information about the team that finished second in the 2023-2024 Premier League city where it played its last match. Therefore, I cannot answer the query based on the information. So it's provided some feedback and we've gone in false again. I'm not going to read all of this because I think I don't want to bore you with all of the details. But you can pause on screen and read it for yourself if you wish. So we're back to the planning agent and we have now actually adjusted the most important search to 2023-2024 Premier League second place team. That's good. That's good. So it's taken on board the feedback and it's adjusted that search. And that search is a way more sensible search. That's what we want to do. And then we're back to the integration agent. So the integration agent has correctly identified that Arsenal was the second place finish team. So the team to finish second was Arsenal. And then it says, according to the research provided, Arsenal's last match was played on the 11th of May, 2024 against West Ham United. That is not accurate. It's not true that Arsenal's last match was played against West Ham United. And I'm not sure that this is right. I think that's a hallucination. And it says it's picking it up from this Wikipedia page. So it says, even says the source, and it tells us for information about the team that finished second and the city where its last match was played. Let's have a look. Let's see. I think we're going to struggle to find. We are going to struggle to find this. I think we're going to struggle to find that West Ham reference here. Right. So I'm not going to look through this entire source and find out where West Ham was referenced because it is a pretty long document, but it's not true that Arsenal's last match was played against West Ham United. However, it is true that the city where Arsenal played the last match was London. So the largest city north of London is Edinburgh. That's not correct. The largest city north of London is Birmingham. And I've noticed a few models have this information in there incorrectly in the weights. That's not true at all. But what's interesting is we have now gotten to the point where we've identified a city. And then we've got some feedback to the planning agent. So it's saying the current weather forecast in Edinburgh. Let's find out if we actually get a weather forecast. Let's keep going. So we're back and we've identified a search again. So we're kind of looping back to this 2023 Premier League second place team, which we don't need to. We already know that information. So we're back here again. And, you know, the quality assessment agent has marked that as false. That doesn't pass, but let's continue going. We are back to the search query. So, yeah, we're back to the planning agent. That's interesting. Cristiano Ronaldo's country. I think I know what's happened there. So because it failed on the last response, it's actually picking up some errors here about it's picking up the wrong information. Because remember, the integration agent writes its response to a memory.json file, and that gets wiped once the agent circuit is completed. But because it failed in the last response, the agent circuit didn't get wiped. And I forgot to go in and wipe that. But anyhow, it seemed to kind of have corrected itself. Let's see. Let's go further and see what happens. So we've got another response from the integration agent. That's false. That doesn't pass. Here we go. So we have then we're going back and forth with this 2023 Premier League second place team, which we already know. Let's keep going. Doesn't pass. Here we go. So now we're back to the planning agent again. And one of the searches is current weather forecast in Edinburgh. And we've identified the most important search as the current weather forecast in Edinburgh. That's good. That's actually pretty good that we've actually managed to identify that. We pass that to the integration agent and we've got some weather. Now, let me tell you, this is the first model to actually be able to get to the weather. And that's, you know, even with the memory.json error that I just talked about, where the memory had overlapped from the previous run, and we had some information about the previous question. We had some memory from the previous question. So managed to get around that and actually get to a weather forecast for Edinburgh. Now let's just make sure it's correct. Now weather forecasts do move, and I did do this a while back. I did this a few hours ago, so hopefully it's still relevant. I'm going to pick out the weather forecast. And so we are saying, let's just make sure this is for Edinburgh. It looks like it is. I can't see Edinburgh mentioned explicitly here. I can just, here we go. Yes. So it's AccuWeather. It is Edinburgh. And what are we saying the current temperature is? So we're saying a current temperature of 10 degrees, which, to be fair, would have moved from the point that I initially ran this. It would have moved from that point. I'm not going to lie. It says light rain. So yeah, this is a little bit of a tricky one, because definitely the weather has moved from when I last ran this. I ran this a few hours ago, and I'm only just going through the results now. So I think this has actually been a pass. And the reason I say it's a pass is because even though the exact weather has changed, because I ran this a few hours ago, you can tell by the fields that this is pulling from this AccuWeather site. And it's close enough for me to believe that this is just, the numbers are different just because it's a different time of day that I'm accessing this site. So that's a pass. That's amazing. I guess, well, actually, let me not say it's a pass. I think I'm going to award it half marks. And I award it half marks because it still failed in the fact that Edinburgh isn't the largest city north of London. It's actually Birmingham. But if it had managed to get the answer that Birmingham is the largest city north of London, we would have been able to get the weather. And this is the first model that has been able to go all the way and get the weather. That's amazing. All right, I'm going to tally up the points. I'll tally up the score for this Codestral model. We can compare it with all the other models. And then last, I'm going to do a live run through of the GPT4o model, and let's see how well that does as an agent. So perhaps you're as surprised as I was about the performance of the code model. I think it's actually one of the best performing models that I've tested in this series. So let's go through and tally up the results. So question 1 was a pass. It managed to answer that successfully. Question 2 was a pass. Question 3 was a pass. Question 4, we got wrong. We didn't identify correctly that it was Tyson Fury that was the loser, and therefore we got the wrong answer for the birthplace of the loser. Question 5 is a pass. We managed to get some cheap flights with some correct information there. Question 6 was a fail, and that actually ended up crashing the model and breaking it. So question 6 was a fail. But question 7, I'm going to award half marks to, because just the fact that we managed to get to a weather forecast, even though we got this city, the largest city north of London, wrong. It should have been Birmingham. We got that wrong, but we managed to get to the weather. And there is something to say about that, because no other model has managed to do that. All the other models have either run out of iterations before they could get there, or they've crashed out. And that was despite the fact that there was an error when I was running it, because it had pulled some of the context from the last run on question 6. So given all of that, the total for the Codestral model is 14.5 points. And I believe that actually puts it on par with the Llama 3 10x chat 70 billion model. And I think it also outperforms the Llama 3 70B instruct, which is really impressive, and almost on par with Perplexity. By the way, this is obviously the free version of Perplexity we're talking about here. But for a 22 billion parameter model to outperform some of the larger models here, and also to be on par with the 70 billion parameter model, is really impressive. And it just goes to show there is probably something to using these code models where you need some amount of reasoning capabilities, because it seems like these code models learn reasoning from being trained on large volumes of code. That's interesting. And, you know, I wasn't really expecting that result. I thought it would do well, but not quite that well. All right. I'm going to do a live run of GPT4o next, so please stay tuned for that. Give us your opinions in the comment section about the code models. If you've tried this before with agents, if you tried larger code models, let me know. All right. I'm going to do a live run of the GPT4o model. Before that, I'm just going to show you how I set that up. So you can see the last model I tested here was Codestral. So if you are running the script for yourself, what you want to do is head into the agent.py file and comment out the server you're not using. So we're not using runpod this time because we're moving on to GPT4o. Of course, you're going to need an OpenAI key to run any of the OpenAI models. So I've commented out runpod, and I'm going to uncomment OpenAI. I'm going to change the model to GPT4o. And I'll do that for every model. And I believe that's how you call a model. I'm just going to double check actually before I run the agent workflow, just to make sure that that is the case, that that's how you call the GPT-4o model. I believe that's how you call it. Once you've done that, hit save, and then we're ready to actually run the agent workflow. Great. So I have now got the GPT-4o model. I've set that as a parameter, and I've hit save. So now I'm going to start the agent workflow. So this is a live run through, and we're testing all of the questions that we tested with the open source models. And this will be good for you to see how it all works live. And part of the good thing about GPT-4o is that it's incredibly speedy. So this shouldn't take too long. So what you want to do to start this is you want to run Python agent.py run. And then you ask to enter a query. So the first query is, when did the capital of Nigeria change? So that's the first query. Let's run that and let's see if we can get some speedy responses from GPT-4o. So that's very speedy, especially even in comparison to the models I was using before. So we are failing to pick up some sites, but hopefully we can actually get to a site that we can visit, and we're here down at the BBC. And great, we've got an answer, and that's clean. So I'm not going to go through all of the details of that, but you saw how that worked live, and we've gotten to an answer. And it's the correct answer. Nigeria changed its capital from Lagos to Abuja in 1991, and we're picking up a source here. So that looks quite clean to me. Let's see the source itself. Bear with me while I pull up the source. I'm just cleaning up some of the existing tabs I have here, just to make things a little easier on the eye. Okay. So we have a source. Let's have a look at the source. And here we go. Abuja replaced Lagos as Nigeria's capital in 1991. That's a pass for GPT-4o, as expected. Let's move on to the next question. And once again, to ask this next question or to run the agent, you run Python agent.py run. Right, we're prompted to enter your query again. So I'm going to enter the query. What is the current population of NYC? That's the second question. What is the current population of NYC? While that's running, I'm going to record our position. So we had a pass on the first question, and on the second question, we're doing that now. So notice it's really concise. Obviously, GPT-4o is probably the best model out there right now. So no surprises here, really. Let's see what it does with this custom web search agent. And you can see already it has, planning agent did come up with some sensible queries. But here we didn't pass the quality assessment, and it's because it does not provide actual current population figure. Fine. So hopefully we pick up another source. And we've done another iteration, says it does not provide the most current population figure for New York City, which is the main query. The response relies on data from 2018. Ah, great. Oh, we have gotten to an answer. Let's see what that answer is. So it says, based on the information provided, the most current population estimate for New York City is from April 1st, 2020. As of that date, the enumerated population of New York City is 8.8 million, and I recognize that number. And also I recognize this link, and I can say that that is a pass. I'm not going to go into the link because I think we've done that several times in this video already. So that's a pass for that question. Let's move on to the third question. Let's run Python agent.py run. And the third question is, who won the Premier League 2023-2024 season? That's the third question. And we're just running through this agent workflow again. Sensible queries from the planning agent. It's the least I'd expect from GPT4o. And notice this is it's fast. It's obviously much faster than the local models. You'll see from some of my earlier videos where I was running through some of the models I self-hosted. So we've gotten to an answer. And what we have is a final response. Manchester City won the Premier League 2023-2024 season. The victory marked their 4th consecutive title and their 8th Premier League title overall. And the source here is the Wikipedia Premier League page. And we've already visited this page once before. Just for those that are ultra skeptic, I'll pull that page up so you can see it. And 2023-2024 season. We're including a bracket here, which is just a nuance of picking that out from the PowerShell. But yep, there you go, Manchester City champions. That is another pass, which was expected. So I did expect it to pass the first three questions with flying colors. Some of the models have struggled with the multi-hop question. So let's see how it responds to our first multi-hop question. And I'll do that by running Python agent.py run again. And we are ready to run the question. So let's the first multi-hop question is, what is the birthplace? Let me make sure I get the spelling right. What is the birthplace of the loser of the boxing match between Tyson Fury and Usyk? Let's see. So I am expecting it to get this question right. And it's, look, here you go. It's correctly identified. It needs to get the Tyson Fury versus Usyk boxing match result first. So we're searching for that. And we'll get the answer to that. And now it's identified that we need to get the information about Tyson Fury's birthplace. Here we go. Most important search, Tyson Fury's birthplace. So this is working exactly as it should. This is the design. This is the intended design of the system. So it's done the first step. Now it's doing the second step. And there we go. And it's given us a result, but it's come back as false. And I wonder why that is. Includes, however, it does not comprehensively, because it assumes Tyson Fury is the loser without providing evidence or context from the actual match result. Ooh, interesting. Interesting. God, that's not good. That's not good at all. That's not good. Maybe the agent is too clever. Maybe the quality assurance agent is too clever for its own good, because it looks like we answered that question a while back, but it's kind of going on to say it's not providing context that Tyson Fury is the loser. And we're not able to pass the quality assessment. Ooh, that's not something I expected. That's interesting though. And we're stuck in this loop. That's super interesting. That is not something I expected. Really interesting. Really, really interesting. Okay, so we have actually got an answer here. But what you can see on screen, what's happening is it says the response is relevant and coherent. So this is, by the way, the quality assessment agent. So it says the response is relevant and coherent, and it includes the citation. However, it's incomprehensive because it does not provide information about Alexander Usyk's birthplace, which is necessary to fully address the query. That's not true. It's not true that Alexander Usyk's birthplace is necessary to fully address the query. And yeah, it seems to have gone wrong a while back, because the first time around, we actually responded with the correct answer. So it says, based on the information gathered, Tyson Fury is the loser of the boxing match between Tyson Fury and Alexander Usyk. Tyson Fury was born in 1988 in Wivenshaw area of Manchester, England. That is the correct answer, and we've provided a source for that. Let's pick up the source. And it always kind of gives this bracket at the side here, so just be mindful of that. Let's see where Wiven. Yeah, there we go. Fury was born in 1988 in the Wivenshaw area of Manchester. Yeah, so that's correct. But it's the quality assessment agent that is actually making it fall over, because the quality assessment agent is now saying, on top of that, the response is relevant, coherent, and includes citations. However, it is not comprehensive because it assumes Tyson Fury is the loser without providing evidence or context from the actual match result. Now listen, that is definitely a bug with the agent, with the custom agent. And I'll take a moment to explain why I believe that is. So the quality assessment agent is obviously not aware. It's obviously not aware that the first step of this question already answered the point about Tyson Fury being the loser. And we can see this if we actually go into the code, because we can look at the code for the quality assessment agent. So I'm going to pull that up and we'll step into the code a little bit. So this is what we're doing with the quality assessment agent. This is the check response. So if you look at what we're feeding into the system, and you can look at this that's for the Mistral server or the ROMpod server. And this is for the OpenAI server. So it has the query, it has the response. We should probably give the quality assurance agent an awareness of what was previously responded to. And I know technically this isn't a comprehensive test. It's not scientific, because if I change this now, it does invalidate somewhat the test done previously. But I think in this case, it's different. And here's why. For a lot of cases beforehand, it wasn't necessarily failing because of the quality assurance agent. I think there was only one case where it was failing because of the quality assurance agent. And that was the GPT 3.5 turbo model, but that was just passing everything. Most of the failures were due to the reasoning capability of the large language model. It's completely unscientific, I know, but I would like to give this GPT4o a proper test to see how far we can go. So what I'm going to do is I'm going to make a live amendment to the code, and I'm going to include within the check, I'm going to include the memory.json. So the quality assessment agent is also aware of the previous answers that we've given it. And I think that should solve the problem. So I'm going to just give it a pause here and make those amendments, and I'll come back to you and explain how I've made those amendments. All right, I have made some changes to the quality assurance agent. So this process of checking the responses to see if they meet the certain standard. So including this previous response means that now the agent that's responsible for checking the responses from the integration agent and passing them has an awareness of the previous responses that the integration agent gave. There's a second change, which I've included in the prompt, which is the previous response may partially answer the original user query. The response may likely contain some information from previous responses. You should consider this when checking the response quality. Maybe that could be worded a little better. So what essentially we're trying to do here is we're trying to tell the quality assurance agent that, look, some of the information that you're going to see in the response is a culmination of information that was in previous responses too. And that's to avoid the situation where it says you're just making things up. We're not making things up. It was in the previous response. There was a citation provided and all that type of stuff. So I want to make sure that the integration agent is aware of this. And hopefully that should solve that problem of where we get to the correct answer. But because it was a multi-hop problem, we just continue in the loop and the quality assurance agent doesn't pass it. Again, I know this is unscientific. I know that, I should keep this thing exactly the same. But this isn't really a science experiment to the strictest word. It's more like it's kind of a shared engineering exercise. Let's put it that way. So I've made that change. I'm going to hit save. And I'm going to make sure I hit save on the agent change. And I'm just going to make sure that I'm giving these things as they should. So I've said previous underscore response. I think it should be clever enough to pick that out, but I will just call it previous response just to make sure that the language is the same. Right. I've hit save on that. Okay. Let's go back and let's try again. I'm going to try again from the Usyk theory question. I'm going to try again and see if that's made any difference at all to how we get to an answer. Hopefully it has, fingers crossed. Otherwise, you're going to see this fail in real time, which isn't necessarily a bad thing. So I'm just navigating to the questions again. I'm going to run the agent, Python agent.py run. Apologies for that. It's actually down at the bottom here. There's some weird stuff going on with the formatting. And the question is, what is the birthplace of the loser of the boxing match between Tyson Fury and Usyk? So what is the birthplace of the loser of the boxing match between Tyson Fury and Usyk? Let's try that. And fingers crossed, we get to the answer this time without entering that infinite loop where the quality assessment agent doesn't pass it. Let's hope so. What is refreshing is obviously testing this with a speedy model. So we're following the same logic flow, and quite rightly, we fail the first one because we need to find out the birthplace of Tyson Fury. I'm actually quite nervous to see how this works because I am doing this live. I don't know if it's going to work. And it hasn't worked. I thought it would get it on that second try, but apparently not. Ah, yes, we've got it. We have got it. So we have a final response, and you can see, based on the information gathered, Tyson Fury is the loser of the boxing match between Tyson Fury and Alexander Usyk. Tyson Fury was born in 1988 in Wythenshawe area of Manchester, England. And we have our source. Where is Tyson Fury from? And it's given us the Sporting News. And we also have the sportingnews.com. So it's the same article, actually. It's the same article. That's good. That worked. And I wonder why it rejected it the first time around, because it seemed to got to Wythenshawe already. And it says the response is comprehensive as it fully answers the question by identifying Tyson Fury as the loser and providing birthplace. Additionally, it includes the citation linked to source, which supports information. So why did it say it was false? What was the reason? Relevant, coherent, comprehensive citations. Reason, the response. Yeah, that just seems to be an error there. But yeah, it worked. It worked in real time. Okay, so I am going to give that a pass. Yeah, I know it's unscientific, but it is what it is. I'm going to give that a pass. And we will move on to question 5. And let's run the agent workflow from the top. So Python agent.py run. And it's prompting us to enter the query. So the query we want to enter is find me the cheapest flights. Find me the cheapest flights to Barcelona from London for one adult leaving next month. So find me the cheapest flights to Barcelona from London for one adult leaving next month. Let's hit it and let's see what happens. Okay, sensible queries once again. The issue with changing large language models and agent workflows in real time is you don't know how it's going to affect everything else downstream, but hopefully it shouldn't have a negative effect. So yeah, we're failing to retrieve from Kayak. Hopefully we can move on to another site. Mondo, we failed again. And notice GPT4o is a much more capable model, so it's able to just move on to the next sites. Maybe I spoke too soon. Oh, no, it is. Yeah, so we're on Skyscanner. Some of the models get stuck because they can't unpick the prompts that tell them to move on if a site failed. And notice this is really nicely laid out too. This is really nicely laid out. And actually, we're returning a false here. I wonder why that is. The response is relevant to the query, provides a coherent, well-structured. However, it does not fully address the queries. It only provides two specific flight options and does not offer a comprehensive search or a broader range of options. Additionally, the departure dates mentioned do not align with the request for flights next month. Interesting. Which would be November 2023, not July 2024. Oops. Oh, that's wrong. That's wrong because it should be aware of date time. And again, this is the quality assessment agent failing because the quality assessment agent doesn't have an awareness of date time. And I guess when you're using a more intelligent model, these are things that you need to bake in. So I guess you know what I'm going to do next, because I think GPT4o gets the answer to this, but we need to bake in that date time into the quality assessment agent too, so it's aware of date time. The model is almost too clever for itself because one model is aware of the date time and the other model is not. And it's not explicitly mentioned by the integration agent what the date time is because that wasn't the question. That wasn't the original question. So what I'm going to do is I'm going to let this time out. I'm going to let this get to I'm going to let this run through all of the iterations, and I'm going to adjust the code once again to include the date time. So what I'm going to do is I'm going to go to the agent.py, and there's a function to actually include date time here that I've written. So right now, all of the other agents are aware of the date time, apart from the quality assessment agent. And let's find out where it is. So get current date time. I just want to find out what I've called it. So date time is get current date time. We're going to pick that up and we are going to, that's the integration agent. We're going to do the same thing for checking the response quality. So date time. And we can set that as a default value, I believe. Let's just set that as get current date time and we will make it aware of the date time. This is current date time. So now it should have an awareness of the current date time because we've given it that timestamp. And we will do the same here too. So I'm changing it in these two places because one is for running local models. And yeah, so one's for running OpenAI and RunPod models, and the other is if you're working with the Ollama local models. So that's why I'm doing it in two places at once. I think this could probably be an if Ollama rather than just an else. But it is what it is right now. I'm not going to get into a huge refactor at this minute. I hit save on that. And then I just need to make the adjustments here by passing in for check response, that last thing. No, I don't, because date time is already set. I believe date time is already set. It has a default value already, so I don't need to provide a value for date time. And that's perfect. So I'm going to pull this up once again. And you can see predictably, we didn't get a true for this answer. And I'm going to run Python agent.py run. Python agent.py run. Before I do that, I just want to double check that I actually saved what I changed. So I did hit save on that. Python agent.py run. And then we'll do that again. Find me the cheapest flights to Barcelona from London for one adult leaving next month. Let's have a look. And hopefully, if this has all worked, the quality assurance agent should be aware of the date time and it won't fail our quality check. And, you know, this is actually a testament to how intelligent the 4o model is. It's really checking the quality. You're not going to fool it. You know, if you're providing, it's actually checking that it meets the query in its entirety. And that's something that the other models didn't do, and they weren't falling over for the same reasons for the quality assurance agent. So that is interesting. That's something I've picked up by running this live test. We're revisiting that, and hopefully, if I've programmed this right and haven't done this in a stupid way, we should actually be providing coherent responses that pass the quality assessment. False. The response is not relevant because it provides flight information for dates in September, October, November, whereas the query specifically asks for flight leaving next month. Okay, let's see if we get there. So next month, at the time of recording this video, it is June, and next month is July. So let's see if we do get there. Hopefully, you know, this doesn't bug out because it pulled from Skyscanner last time. Requested next month. Right, let's just see. There is a mechanism here that doesn't allow it to visit sites that it's already visited. And I think that might be causing it some issues. You can see this in real time. That might be causing it some issues because where it's visiting sites that it's kind of, it should just revisit Skyscanner basically and pull the information. But hopefully it should act on the feedback and just remove the superfluous information. So what are we saying here? Instead, it provides details for flights in September, October, November. While the response is coherent and well structured, it fails to address the query in its entirety, making it incomprehensive. The response does include citations and links to sources. We are running into some problems. And I wonder if it's actually because there are no flights for next month. That might be the issue. That might be the issue. But the quality assurance agents should pick that up. It should pick up that there aren't any flights for next month, and it should be able to pass this. And it's continually registering as false. I think that's an issue. I think that's an issue. It should be intelligent enough to know what the integration agent is telling it, and it should be able to adjust its approach based on that. But it's not intelligent enough to actually pick up that, look, there aren't any flights in July that we're picking up from the website. But maybe, again, this could be good because it forces it to go and find a different website, but it's not doing that. This might actually be a fail for this question, which is interesting. This is super interesting. It might be a fail for this question. Yeah, you can kind of see where the quality assurance agent is saying the research provider does not include specific information about cheapest flights from London to Barcelona for July 2024. And I know that because I visited that Skyscanner site. It just has flights for September, October, and November. I would expect the quality assessment to understand that and note that and pass it because, okay, it's incomprehensive, but it's the best we can do. But the quality assessment agent returns that as false. So it's almost too strict. It's like an overly strict bureaucrat as a quality assessment agent. And I wonder if we could get better performance out of the system as a whole by using GPT 3.5 Turbo as a quality assessment agent rather than GPT4o. That would be an interesting experiment. So I'm going to hit a fail on that one. So interestingly enough, question 5 is a fail, and some of the other models were able to get to an answer, but question 5 does get to an answer. I guess, strictly speaking, I won't call it a fail. I'll give it half points because it did get to an answer, but the quality assessment agent was bugging us out. And we know that this is the correct thing from Skyscanner. I've already checked these for previous flights. So I'm not going to go into the details of this. You'll know if you've watched the previous parts of this video. Let's try the remaining 2 questions. So Python agent.py run. The next question is our multi-hop question. This is the one that tends to trip all of the models up. How many Germans live in the colonial holding in Aruba's continent that was governed by Cristiano Ronaldo's country? How many Germans live in the colonial holding in Aruba's continent that was governed by Cristiano Ronaldo's country? So the grammar, let's see if the 4o is intelligent enough to deal with this. Right, okay. So straight away, we have what looks like a good plan, I think. What continent is Aruba located in? Yes. Which country governed Aruba during its colonial period? What is the German population? Let's see. Let's see what it does, because that doesn't seem like the right approach. But let's just see. This question has been tripping a lot of the models up, and I'm going to put it down to the grammar. I think grammar is terrible in this question. It was artificially constructed. I used a research paper as the basis for this question, and I made a slight amendment to it. So the research paper initially takes 4 single hop questions and puts them together to form this multi-hop question. But I have made a slight amendment to it. And even the one in the research paper is not completely all there in terms of grammar either. So we've gotten to a stage where we want to find Portuguese colonies in South America. Let's see if we do actually get that as a search. Current German population in former Portuguese colonies in South America. Okay. So I would expect it to be able to break that out into former Portuguese colonies in South America. I would expect it to be able to do that. Although we have gotten to this German-Brazilian number again. We have gotten to this German-Brazilian number again, which is interesting. And I can see that we have the right answer in there somewhere. I can see that we've got a population between 5 and 12 million. But yet again, this quality assessment is killing us. The quality assessment is not really doing the right thing here, as this should be passed. And it'll be interesting to see when we get to the end of it why we haven't gotten the right answer from the quality assessment. That's the right answer. I can see it there. You can see. So yeah, we time out again, and we see final response. Based on the information provided, here's a comprehensive response to the query. The query asks about the number of Germans living in the colonial holding in South America that was governed by Portugal, the country of Cristiano Ronaldo. The research provided does not include specific information about current German population in former Portuguese colonies in South America. However, the research does provide a detailed history of German migration to Brazil, a former Portuguese colony in South America. I mean, surely that is the answer to the first one, right? About current German population. So according to the source, approximately 260,000 Germans settled in Brazil between 1824 and 1972, and the number of their descendants on Brazilian soil is estimated to be between 5 million and 12 million. 5 million is the correct answer. That is actually the correct answer, but our quality assurance agent didn't pass the answer. So I can't give it full points. And let me just check that it is pulling from the source and it's not just making this stuff up. I'm putting up the Wikipedia article that we have. I'll do a search. Control 5 million. There we go. Cited 5 million Brazilian of German descent. Okay. That is the correct answer. That's what we're looking for. And it's cited in the Wikipedia page. Right. So again, the quality assessment agent is extremely strict. And maybe it's because the criteria I have are it's almost too strict. Maybe the quality assessment agent, setting it to a temperature of 0 is also causing some issues. So that'll be interesting to see as well. That'll be an interesting experiment for another day. Let's run the final question. By the way, I'm going to give that half points because we did get the correct answer, but we didn't get it past the quality assessment agent. Let's run the final question. Python agent.py run. And the final question, let me remind myself of what that is. It is another multi-hop question that is a bit long-winded. Forgive me, I'm putting it out on a separate window. Final question is, what is the current weather forecast in the largest city north of the city where the team that finished second in the 2023-2024 Premier League season played its last match? Okay, so this is another multi-hop question, as we've gone into the details of this previously in the video. Let's see. So far, only the Codestral model managed to get to an answer for this. Let us see if we are able to get to an answer. So already I can see it's kind of starting off on the wrong foot. We want to actually understand which team finished second in the Premier League first. That's what we want to understand. And let's see if we can get an adjustment there. Current weather forecast in Manchester. That's completely wrong. That's not correct at all. So yeah, because we started off on the wrong footing, the model has gone in the wrong direction completely. And maybe this could be, given this model is really capable, maybe this is being caused by the prompting of the planning agent. Maybe the prompting of the planning agent could be a bit more sophisticated when dealing with these multi-hop questions. So I'm not going to change that because there was a few this has been a common theme across all the models. The planning agent hasn't necessarily identified the right hops to solve some of these queries, and this one is no different. So I won't be changing that, but I suspect if with a little bit more sophistication with the prompts, we would be able to get a response here that was correct. And notice the data quality, the response quality assessment is failing each time. And I bet it's something to do with the not identifying the correct, like the team that finished second place and then identifying where they played their last match. I bet it's something to do with that. There is probably something about the feedback loop here as well. I think I've made it so the feedback from the quality assessment also feeds back into the planning agent, but it definitely feeds back into the integration agent. So the integration agent should take that on board when it's creating its own feedback for the planning agent. But certainly these prompts could be optimized. So let's see what happens. It lacks links to sources. I see. Okay. So based on the research provided, here is a comprehensive response to the query. Identify the team that finished second in the 2023-2024 Premier League season. Arsenal finished second. So it's found that, but there's no link to the source. Find out where this team played its last match of the season. It played against Everton at Goodison Park in Liverpool. That's not correct. It did play against Everton, but it wasn't at Goodison Park. It was in London, actually. Determine the largest city north of the city where the last match was played. The largest city north of Liverpool is Manchester. Fine, if it is indeed Liverpool, but it wasn't Liverpool, it was London. And then we've got a weather forecast for Manchester. And yeah, there's the issue. There's the issue. It's on this second point. It wasn't able to identify that the match was played in London. And I think, to be fair, it is sometimes difficult to identify that because you can usually infer that by which way round they have the teams score. It doesn't always state explicitly that the match was played in London or it was played in Everton. It's kind of, you infer it by what team they mentioned first when announcing the score. And probably the model has some issues with that. So I just want to have a look at the reasoning traces because I didn't clock when it actually found that Liverpool played that match, because from what I could see, it was just searching for weather in Manchester. Let's see. Current weather forecast. That's the debug. Not debug. That's the weather forecast in Manchester. When did it identify Manchester as the city to look for? So that's back to the German question. Current weather forecast for the largest city north of the city where, so that was the search query. And we got some information from here. Premier League. So it must have identified it from this NBC Sports link because we would have been able to see the Premier League standings from here. I'm putting that up on the side so you can see. Yeah, that's correct. So I'm going to pull that over to you so you can see it. But yeah, essentially you could see the Premier League standings here. And you would know that Arsenal finished second. You can see that. And then did it pick up? Where did it pick up that Arsenal played against Everton? It's somewhere in this article because there's no way that they would be in the model's training data unless they have retrained GPT4o at the time of recording this video, which I think is unlikely. I'm just going to see where Everton is mentioned. So it's mentioned 9 times. Everton again. Arsenal's late breakthrough at Everton. So it's inferred it from here. That's fine. So we did pick up that it was Everton, but we just didn't pick up where the game was being played. And that's because it wasn't available in that source, actually. So the data quality assessment agent was right to not pass that in this case. And maybe it's good that the data quality assessment agent is so strict. And if we can improve how the integration agent is prompted, we can probably start getting answers to some of those. Well, not just if we can improve how the planning agent is prompted, we can probably start getting answers to some of those later questions. So I'm going to give that half points. And that's because I did give the Codestral model half points for getting to a weather forecast. Let's just check the weather forecast is actually correct before confirming those half points. So it wasn't the right city, but we got to a weather forecast, which the other models weren't able to do. So I feel we need to reflect that. And I can see straight away it is coming. It is a weather forecast for Manchester. Apologies, it's just crashing a little bit, but we can see 55 degrees. And that's mentioned there, 55 degrees Fahrenheit. Rain and showers. Yeah, 3 miles an hour gusts, and you can see gusting up to 3 miles per hour. So I think this is largely correct. So I'm going to give that half points. And next, I'm going to tally up all of the points for GPT4o, and then we'll be able to see where that lands on the matrix. And it should be no surprise to you that GPT4o performed the best of all of those models. But let's just see what it looks like on the matrix compared to all of the other models. Right, let's tally up the responses. Let's tally up the results for GPT4o. First question was a pass. The second question was a pass. The third question was also a pass. And the fourth question was a pass. The last 3 questions, I awarded half points to. And that was primarily because the data quality agent, so for question 5, the data quality agent wasn't. And the response quality assessment failed. For question 5, even though we did get some flights, so I awarded half points for that. The same for the question 6. The response quality assessment failed, so I awarded half points for that. And Question 7, the response quality assessment failed, and it also identified the wrong city. But getting to the weather forecast, I feel that there needs to be points awarded for models that were able to get there versus models that weren't. I think the only other model that did it was the Codestral model. So I awarded half points for question 7 too. And that gives us a total of 17.5 points for GPT4o. And let's see where that puts us in the standings. So as you might have guessed, 17.5 points puts us in the A tier. So I've put it between the A and B tier. So it does outperform Perplexity. But to move solidly, it could probably get into that S tier. But I think that would require some optimization of the prompts, and it would also require some amendments to that data quality assessment agent too. So that's really good. Predictably, GPT4o does outperform Perplexity. I think the base model does outperform Perplexity anyway. It would be good to see how this custom web search agent performs versus the base model. There are definitely some tricky things when it comes to making those data, those response quality assessments, especially as your models get more intelligent. They become the scrutiny, the level of scrutiny that you apply against the responses is even higher. So it does tend to nitpick. And also that puts a spanner in the works on this pattern, I believe, that many people say, where you get the smaller agents to do some of the simpler tasks, and then you get a really intelligent model to act as the manager agent and guide the smaller agents. Something tells me that sometimes those smaller agents won't be able to satisfy the requirements of that really intelligent manager agent. And I think you can see it. You can see it in the way that GPT4o was going through and producing those responses and then assessing itself. It wasn't able to pass its own stringent criteria for a lot of those responses. And quite rightly so in some cases, but in other cases, it did seem a bit too punitive, especially with the flights one, where the model already recognized, the integration agent recognized that there weren't any flights for July. Yet GPT4o wouldn't pass it because it was failing. It wouldn't pass it because it wasn't returning flights for July, even though it explicitly said that we couldn't pick up any flights in July. That's something to be aware of. If you like this content, subscribe to the channel, give the video a thumbs up, give your opinion on what you've seen, and let me know any improvements that you think I could make to this custom web search agent so it can consistently outperform Perplexity. Thank you, and see you on the next video.